Hello, I'm Jingnan.
Hello, my name is Chong Jiashuo.
And I'm Joe.
So today we'll be presenting our project about integrating bees into commercial urban farms. So commercial urban farms have advanced drastically over the years. These farms use advanced sensors to ensure optimal environmental conditions for plant growth. Some may even make use of advanced and novel technologies such as artificial intelligence to aid in their operations. We have concluded that it will be extremely difficult to enhance something with respect to technology within the urban farming sector. However, there is a certain topic that is still relatively underdeveloped in the urban farming sector, and that is pollination. Since there are no natural pollinators in commercial urban farms due to its enclosed environment, growing crops in these urban farms they are reliant on pollination is very difficult. Some farms that try to grow said crops pollinate the crops manually, which is inefficient and time-consuming. As such, our project will target this issue that is pervasive in many urban farms. We will introduce a reliable and efficient way of pollinating crops. We came to this idea of integrating a natural pollinator, such as bees for instance, into urban farms. Roughly, it will look something like this. Now, the challenge for us is to determine what is successful integration of bees, which happens to be our driving question. So, we have determined two issues that need to be addressed. Firstly, there must be high crop yield. Over-visitations by bees may result in reduced yield and deformed crops. To solve this, we will count the number of bees going into each farming section and dispense scents that either attracts or repels bees, depending on if the farm section has too little or too many bees. Secondly, there will be some form of automation. One form of automation that comes to mind is the monitoring of the health of the bees so that periodical checkups on these bees may no longer be necessary. We will measure the temperature and humidity of the beehive. Usually, the optimal humidity range is 50 to 90%, depending on the section of the beehive. While on the other hand, the optimal temperature range is 34.5 degrees Celsius to 35.5 degrees Celsius.
For phototyping, a lower optimal humidity range is said to be from 50 to 60%, and the optimal temperature range is 34.5 and 35.5 degrees Celsius. This data can be transmitted wirelessly to another device, such that the health of the beehive can be tracked everywhere.
This is the monitoring setup for the beehive. A N5 stack monitoring the environment with an environment sensor wirelessly transmits data to a second N5 stack that will use an RGB module to display the status of the beehive. This RGB module enables remote monitoring of the health of the beehive. Currently, the optimal temperature range is 34.5 degrees Celsius to 35.5 degrees Celsius, and the optimal humidity range is 50 to 60%. Both conditions are currently not met, hence the RGB module is displaying the color red. Now, in this example, we have reduced the temperature range to demonstrate what happens when one condition is optimal. One of the LEDs on the N5 stack will change from red to green. This indicates that one of the two conditions have been met. The display on the second N5 stack will display a warning message, and its RGB module will turn yellow. We have reduced the humidity range in this N5 stack for this example to demonstrate what happens when two conditions are optimal. Both LEDs on the N5 stack will change from red to green when both conditions are met. The display on the second N5 stack will show an OK message, and its corresponding RGB unit will display green. Now, I will demonstrate this N5 stack wirelessly transmitting data to this N5 stack. With this N5 stack measuring the temperature and humidity, since the temperature is too low or humidity is too high, this N5 stack is displaying a status of danger and signaling the RGB unit to be red. So now, this is the code that the N5 stack measuring temperature is using. So when I reduce the lower temperature limit to 20, And now I will change this N5 stack to internet mode so that I can update this code. And now I will download this code onto N5 stack. Alright, so this is updating. Okay, so now one condition should be okay, and as in here, the status changes from danger to warning with the RGB LED displaying yellow now. This is because one condition is now optimal as opposed to previously where 0 condition is optimal.
This is the setup for tracking bee movements in and out of farming section. Here we show the bee moving in. And here we show the bee moving out. This shows the bee moving out before deciding on going back on that decision. Here in this example, we have 9 bees that have already moved out. For the sake of the example, a motor acting as an almond scent dispenser will be activated on 10 bees to discourage bees from going that.
This is the summary of all the parts we have used for the making of this project.
Thank you for listening to our project.